Friends, now I am going to discuss fluid properties. Okay, so fluid properties. In last class, we discussed different types of fluids. Okay, now this is fluid properties. What are the important fluid properties that we are going to discuss? Okay, so first of all will be mass density. Mass density. It is denoted by rho. Number 2, weight density. Weight density. That is denoted by gamma. Then specific gravity. Specific gravity, that is denoted by Fs. Number 4, specific volume. Specific volume, that is Vs. Number 5, absolute viscosity. Absolute viscosity, that is mu. Kinematic viscosity. Kinematic viscosity, that is nu. Then surface tension. Surface tension, that is denoted by sigma. So all these properties one by one we are going to discuss in today's session. Okay, so first of all let us define what is mass density. Okay, so number 1, mass density. Mass density, it is denoted by rho. Definition. What we have to study in these things, all these fluid properties, what is its definition, what is its notation, how we are going to write mathematically, and if equations are there, then we have to apply those equations also. Okay, so mass density rho is equal to mass per unit volume, that is your mass density. Okay, so how you can define mass of a particular fluid? Mass of fluid per unit volume. Per unit volume is known as its mass density. Mass density. It is denoted by rho. So rho is equal to mass per unit volume. Okay, or you can define in another way, ratio of mass per unit volume, mass of the particular fluid to the volume of that fluid is known as mass density. Okay, so here I have written mass density rho is equal to mass per unit volume. Mass of the particular fluid per unit volume is known as its mass density. It is denoted by rho. So that is unit wise, mass is in kg, okay, and volume is meter cube. So remember, this is in SI units. Okay, we have to discuss only in SI units. That's why I am not giving you the unit of rho in MKS units. That mass will be metric slug by meter cube. So that is confusing. Better not to learn those things, because we are going to solve the numerical, and we are going to study only in SI units. So kg per unit volume, that is kg per meter cube, is the unit of mass density of the fluid. Now rho for the water, standard fluid is water, so we have to take it as 1000 kg per meter cube. It is standard fluid. Okay, so if it is not given, then we have to assume this value. That means standard fluid is water, standard liquid is water, and this is for standard fluid, and that is for air also. We can take air, that is 1.2 kg per meter cube. Okay, that is also, this is for standard fluid, that is liquid, and that is for air. This is, if it is not given, we have to assume these values. Okay, so this is about your mass density. Now let us discuss weight density. Weight density, it is denoted by gamma. So gamma is, weight density is defined as the ratio of weight of the particular fluid to the per unit volume. Okay, so it is the ratio, weight density is nothing but, it is the ratio of weight of the particular fluid to the volume of that particular fluid is known as weight density, and it is denoted by gamma. Unit, if you talk, weight is Newton per meter cube. Okay, so that is in SI units. Here also, if we talk about MKS units, that will be kgf. Weight unit in MKS units will be kgf per unit volume. But here also, not to remember that unit. Here in all throughout the syllabus of fluid mechanics, we are discussed only in SI units. So weight density of standard fluid, that is here also, that is standard fluid is water, that is 9810 Newton per meter cube. This is for standard fluid. Here also we have to remember this one. So now one important relation is there. What is the relation between weight density and mass density? That is mass density and weight density. Weight density. See, both are density per unit volume. Here also it is per unit volume, and here also it is per unit volume. It is mass per unit volume, it is weight per unit volume. So there is a relation between this one. So we know this equation, W is equal to M into G. Okay, divide by meter cube. See here, meter cube. Okay, so the weight per unit volume, see, weight per unit volume is your gamma. Okay, and mass per unit volume is your rho. So rho into G. Okay, so that is the relation between mass density and weight density. What is that one? Weight density will be equal to mass density into G. G is 9.81. G is 9.81. So if you divide, multiply by 9.81, it will give you us weight density. So let us conclude what we have studied in this session. In this session, we have discussed different types of fluid properties. Fluid properties, in fluid mechanics, we have to study mass density, weight density, specific gravity, specific volume, absolute viscosity, kinematic viscosity, and surface tension. Okay, so mass density is nothing but mass per unit volume, mass of the particular fluid to the volume of that unit. Okay, so it is denoted by rho, and unit will be kg per meter cube. Standard fluid water, mass density will be 1000 kg per meter cube, and weight density is nothing but weight per unit volume. Unit will be Newton per meter cube, and this is standard fluid 9810 Newton per meter cube. This is the relation between mass density and weight density. That is, weight density will be mass density into G. That will give us the relation between mass density and weight density. Rest thing I will discuss in next class. Thank you.